the next part here, number 41 through 45. So when they say f of x equals 4x squared, and they were looking for f of negative 3. So this basically means you have to plug in negative 3 in place of x. Then what we end up getting is 4 times negative 3 squared. That's what we end up getting. What is that equal to? That's equal to 4 times 9, which comes down to 36. So therefore, 36 becomes our answer. Alright, let's look at number 42. So in this case, how are we going to do this one? We have to realize that I'm going to use the equation, absolute value equation, to find the boundaries. And then I'm going to check each boundaries which one works. So I'm going to do x plus 2 of the absolute value is equal to 4. That means x plus 2 equals 4. Or x plus 2 can be equal to negative 4. For the first case, I'm going to subtract 2, so x equals 2. Second one, I'm going to subtract 2, so x equals negative 6. Then this equation will get us the boundaries for the interval that which we are looking at. So whatever we plug in place of x, absolute value and the sum should be less than 4. So let's pick a value that's less than negative 6. X equals negative 7. So what do we get? Negative 7 plus 2 becomes negative 5. Absolute value of negative 5 becomes 5. Is 5 less than 4? No, this one doesn't work. How about between these two? Let's have x equal to 0. When I plug in 0, 0 plus 2 becomes 2. And absolute value of that is still 2. Is that less than 4? Yes, it is. So that works. And lastly, maybe I can consider x equals 3. So when I have 3 plus 2 becomes 5, obviously that's not less than 4, so that doesn't work. So our answer is anything between these two with the open circle. Then what are we looking at? Negative 6, 2, 2, which is choice. 2 becomes the answer. A becomes the answer. Alright, how about this one? So first, I have 81 to the negative 1/4 power, so then the same thing is 81 to the 1/4 power on the denominator. On the numerator, we have 8 to the 2/3 power. Now let me try to do the cube root first. That's cube root of 8 squared. That's another way for me to write it. This one is 4th root of 81. Now, what is cube root of 8? Yeah, that's equal to 2 because 2 times 2 times 2. 3 of those put together becomes 8. So we get to realize that we have cube root of 2 cubed squared. And 81, in fact, is equal to 9 times 9. And each 9 becomes 3 and 3. So what we end up getting is 4th root of 3 to the 4th power. You see, when the exponent and index of the radical, when they match, they cancel away. So we get 2 squared that's left on top. Same thing here, 4th root and then 4th power. They cancel away, get you 3. So therefore we get 4 over 3, which is choice C becomes the answer. Number 44. So in this case, I'm not sure if this one is factorable. So what I'm going to do is I'm going to use the quadratic formula. So quadratic formula is ax squared plus bx plus c equal to 0. In this context, x should be equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Now, then in this case, we get to realize that a equals 3, b is equal to negative 4, c is equal to negative 1. Therefore, x should be equal to negative of negative 4, which becomes 4, plus or minus negative 4 squared, which becomes 16 minus 4, a becomes 3, and c becomes negative 1. All over 2 times a, which is equal to 3. Now 4 plus or minus And here we get 16, and then this is plus 12. So we get square root of 28 over 6. Now I realize that square root of 27 can be simplified. So we get 4 plus or minus 28 is made by 4 and then 7, so we get 2 square root of 7 because 4 can come out of 6. But I can go for one more step further. 2 is common factor in all of them. So my final answer becomes 2 plus or minus radical 7 over 3, which is choice D. Alright, let's look at number 25. So in this case, what are we going to do? Yes, I understand you can plug in these values in because not that many. Algebraically, what you could have done was you can take the square both sides. Then we get t plus 5 should have been equal to t minus 1 squared. But we know that that's equal to t squared minus 2t plus 1. Now, if I have to subtract t from both sides, then we get 0 equals t squared minus 3t because I subtracted t from here and here. And I'm subtracting 5 from both sides, so I'm getting minus 4. Then I know that this can be factored, so t minus 4 and t plus 1. Then you get to realize that t must be 4 or negative 1. Now, at this point, you gotta plug in 4 and negative 1 to check it anyway. So once you plug in 4, we get 4 plus 5 square root. Is that in fact equal to 4 minus 1? So my left side becomes square root of 9, my right side is equal to 3, and they are good. So 4 is one of the answers. Let me check negative 1. So negative 1 plus 5 square root, is that negative 1 minus 1? My right side is negative 2. My left side is square root of 4. So square root of 4, we know that to be positive 2, not negative 2. So therefore, this one has to be canceled away. So our final answer is 4 only. All right. With that, I'm going to close up. I'll see you later.